Inertia, mass, and linear momentum. Inertia is the property of an object that resists changes in its motion. This means that an object at rest will tend to stay at rest, and an object in motion will tend to keep moving in a straight line at a constant speed, unless acted upon by another external force. Inertia is fundamental property of matter and is related to the mass of an object. Mass is a measure of the amount of matter in an object. It is usually measured in kilograms or grams, and it is a scalar quantity, meaning it has only magnitude but not direction. Mass is a fundamental property of matter and determines how much force is required to accelerate an object. And finally, linear momentum is the product of an object's mass and its velocity. It is a vector quantity, meaning it has both magnitude and direction. Linear momentum is conserved in an isolated space or an isolated system, meaning that if no external force acts on a system, the total momentum of the system will remain constant. The formula for linear momentum is P equals mv, where P is momentum, mass is m, and velocity is v. The units of momentum are kilograms and meters per second.
The normal force is the force that a surface exerts on an object in contact with it, perpendicular to the surface. For example, if you place a book on a table, the weight of the book is acting downwards, but the table is pushing back up the book with an equal and opposite force. This is the normal force. The normal force is always perpendicular to the surface and acts to prevent objects from passing through it. The force of friction, on the other hand, is the force that opposes the motion of an object relative to another surface. Friction arises due to roughness of surfaces and the interlocking of microscopic bumps into two surfaces. There are two types of friction. Static friction keeps an object at rest and prevents it from moving, and kinetic friction, which acts when an object is already in motion and opposes its movement.
Good afternoon, my name is Omar Lizama and today I'm going to explain Newton's second law and third law of motion. So to start, Newton's second law of motion states that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. Mathematically, it can be expressed with the following formula. F equals ma, which will be force equals mass times accelerations, where F is the net force applied to an object, m is the mass of the object, and a is the resulting acceleration. This law tells us that the more force that is applied to an object, the more it will accelerate, and that the acceleration will be less if the object has more mass. Newton's third law of motion states that for every action there is an equal and opposite reaction. This means that if one object exerts a force on another object, the second object will exert an equal and opposite force back on the first object.
In physics, work is defined as the transfer of energy that occurs when a force acts upon an object and causes it to move a certain distance in the direction of the force. Work is a scalar quantity, meaning it has only magnitude and no direction. Mathematically speaking, work is calculated as the product of force as displacement, or work is equal to force times displacement times the cosine of theta, where theta is the angle between the direction of the force and the direction of the displacement. The unit of work is the U. So, when theta is 0 degrees, meaning that the force is applied in the same direction as the displacement, the cosine is 1 and all of the force is doing work. When theta is 90 degrees, meaning that the force is applied perpendicular to the displacement, the cosine is 0 and none of the force is doing work. When the angle theta is 180 degrees, it means that the force is acting in the opposite direction to the displacement of the object. In this case, the cosine of the angle is -1, which means that the work done by the force is negative and equal to the product of the force and displacement. Kinetic energy is the energy that an object possesses due to its motion. Any object that is in motion has kinetic energy, and the amount of kinetic energy that it has depends on its mass and velocity. The formula for calculating kinetic energy is 1/2 times mass times velocity squared, where mass refers to the mass of the object in kilograms, velocity refers to the velocity of the object in meters per second, and 1/2 is a constant. This formula shows that kinetic energy increases with both mass and velocity. For example, a heavier object moving at the same speed as a lighter object will have more kinetic energy, and an object moving at a faster speed will also have more kinetic energy than the same object moving at a slower speed.